If you watch a Hollywood war movie, minefields are usually depicted as static, indiscriminate traps, hidden explosives waiting for an unlucky soldier to step in the wrong place. But military engineers view them completely differently. To them, an obstacle is an active tool designed to control exactly where an enemy can and cannot go. This schematic illustrates the 4 core movement vectors a military engineer seeks to achieve. Depending on the mission, they use obstacles to disrupt, fix, turn, or block an enemy armor column. A fixing minefield acts as a snare, holding an enemy formation in place so they can be engaged by massed fires. Meanwhile, the turn vector forces that column to veer off its chosen path and into unfavorable terrain, like a deep swamp or a steep cliff. A properly deployed minefield is an active weapon. It allows a commander to dictate the enemy's speed and their direction. Historically, building these obstacles required a massive logistical footprint. You needed convoys of supply trucks, hundreds of sappers, and days of static manual labor digging holes into the dirt. Modern mechanized armor moves fast. If an enemy tank battalion breaks through your front line, you do not have days to respond with shovels and trucks. This wreckage in Ukraine illustrates the lethal consequence of a stalled mechanized advance. When a fast-moving column is forced to stop or cluster together, it becomes an easy target for follow-on fires. Poland studied these battlefield realities and realized their Cold War-era systems were too slow to react. They needed a way to drop thousands of explosives from a moving vehicle in a matter of minutes, a concept known as scatterable mine laying. In modern maneuver warfare, deploying instant obstacles mid-firefight provides the critical friction needed to stall and dismantle a rapid mechanized assault. Enter the Baobab K. It is a highly automated, scatterable mine layer mounted on a heavy 8x8 wheeled truck chassis. With its wheeled base, the Baobab K hits speeds of 85 kilometers per hour on paved roads. It can rush to secure rear logistical hubs or quickly flank an advancing force along an established highway. But Poland's geography presents a problem. Much of the terrain is composed of dense forests and wetlands, where a heavy wheeled truck will easily sink and get bogged down in the mud. To maintain mobility in those soft soils, Poland is spending 240 million euros on the Baobab G. It utilizes the heavy tracked chassis of the Crab self-propelled howitzer, allowing it to keep pace with armored brigades in deep mud. This diagram illustrates the system's payload. Each vehicle carries 6 automated launchers packed with 600 mines. In under 22 minutes, a single Baobab can deploy a dense grid stretching 1,800 meters long and 180 meters wide. By procuring these 2 different platforms, Poland ensures it can shape the battlefield anywhere, from paved highways to muddy front lines. The onboard computer maintains perfect mine density. As vehicle speed fluctuates, it automatically adjusts the firing frequency to keep the grid uniform. Once laid, it integrates with the Topaz network, mapping exact coordinates and broadcasting them to allied units. Knowing the exact dimensions of that obstacle allows commanders to instantly coordinate precision artillery. They can bombard the trapped enemy armor from a safe distance, destroying the targets without risking friendly fire on their own forces. The Baobab serves as a digital snare, synchronizing physical explosives with a real-time networked artillery system. Permanent minefields carry a strategic cost. While they block an enemy today, they also restrict your own army from safely maneuvering or counterattacking through that same territory tomorrow. The Baobab's MN123 mines solve this by being programmable. A commander can set a timer for the field to self-neutralize anywhere from 1 to 30 days after deployment, dissolving the obstacle to clear a path for a friendly counterattack. This shift makes the minefield a temporary, programmable asset. It becomes a dynamic tool of the commander rather than a permanent scar on the earth. The dual fleet of Baobabs provides the capability to throw down these self-clearing obstacles in minutes, allowing engineers to control the tempo of a battle. Maneuver warfare is ultimately a contest of terrain. With the Baobab fleet, Poland has gained the capacity to manipulate that terrain in lockstep with the speed of the modern front line.